So my talk is going to focus on the health of our waterways today. And I'm going to try and cover these questions. So the first one is, what are the characteristics of our waterways? And Carl's touched a little bit on some of those. What is the health of our waterways? And is the waterway health getting better or worse? What are the impacts on our waterways? And how can we improve waterway health? So Christchurch City has 5 major river catchments. If you look at the map from the top to the bottom, you've got the Otokaikino, which is mainly a rural catchment. You've got the Styx catchment, which is urban and rural. You've got the Avon in the middle, which has our city centre, so it's mostly urban. And then you've got the Heathcote catchment, which has urban and rural. And then to the south, you've got the Hallswell River catchment, which has some urban and then is also rural. And it's cut off on this map because the Christchurch City Council looks after the upper reaches of the Hallswell and the Selwyn District Council looks after the lower reaches. So as Carl mentioned, our waterways are spring-fed, and so they are influenced by groundwater levels. And the Christchurch City Council does a lot of monitoring of our waterways for a range of different things, for consenting reasons, and then also just to uphold our policies and plans. So with respect to waterway health, in a nutshell, I'll go into more detail, but in a nutshell, there are many guidelines that we use to measure the health of our waterways that we aren't currently meeting. And the health of our waterways varies across the catchments. Usually this is influenced by land use, so the waterway health is usually better in the rural areas and not so good in the urban areas. And this isn't a new thing, this happens across New Zealand and internationally, and is referred to as the urban stream syndrome, and it basically means that waterway health is affected by the higher human impacts that happen in urban environments. So I wanted to start with just touching on water quality. I've pulled out the 4 major contaminants that I think are affecting water quality. The first one is sediment, and we look at sediment in 2 ways. We look at suspended sediment, so what you see in the water column. So in the picture there shows a plume of sediment coming from the Addington Brook into the Avon River. So that's an example of suspended sediment. And then there's also settled sediment. So that's what you see on the bottom of a waterway in the channel. So sediment can affect the health of the waterway because it smothers habitat and food for biota. And then it also has a double whammy effect because sometimes it can be contaminated itself with metals and things like hydrocarbons. Sediment can come from a range of different places. It can come from construction sites, so when we do development and the soil gets exposed and we don't have erosion sediment control measures, the sediment when it rains can run off these sites and into waterways. It can also come from other unstabilised surfaces, so for example, if you're doing landscaping, so not building but landscaping, and your lawn becomes exposed, sediment can run off those surfaces into the stormwater system and then into the waterways. And then vehicles can also track sediment onto the roads, and then when it rains, enters the stormwater system and then the waterways. And then of course, as we all know, we've had some effects from the earthquakes, both with sediment running off into the waterways, but then also direct damage within the waterways from bank heave and bank damage and even liquefaction within the waterways. So another contaminant of concern is metals, and we usually talk about zinc and copper when we're referring to metals, that they have the largest effects. In large and high concentrations they can have toxic effects on biota, and they can get into our waterways through the stormwater system from things like brake pads and tyres and building products, so cladding and roofs, for example. And another contaminant of concern that I put at number 3 is bacteria. We're not really too sure how this affects biota. We haven't really gone in too many details, but we do look at it from a human health perspective. So if we touch the water and swim in the water and it has high levels of bacteria, there's a risk that we could get sick. And this bacteria in our waterways comes from a range of different places, so wastewater overflows, as Mike talked about before, but then also from dogs and ducks, which we know more about since we've been doing our fecal source tracking study that Mike also mentioned. So the final contaminant I wanted to talk about was nutrients, and this is just referring to nitrogen and phosphorus. So sometimes nutrients can have toxic effects on biota, like ammonia, but then also nutrients are food for the aquatic plants that you see growing in the waterway. along with having high levels of sunlight. So they need the food of the nutrients, and then they need the light to grow as well. So the nutrients can come from a range of different sources: fertilisers, soils, there's phosphorus in soils, and then also feces as well, so from livestock, dogs, ducks, and also wastewater. So every year we look at the monitoring data we've done for water quality. We monitor 44 different sites at the moment across the city, and we monitor them monthly for a whole bunch of different contaminants. And then we analyse that for the year and write a monitoring report to see what the state of the waterways is with respect to water quality. So from last year's report, because 2015 we're in the process of doing that now, it showed that the best catchment for water quality was the Waterway River. So that fits the fold of what I was saying before about how there's less urban impact, there's better quality out in that catchment. And the best site was in the same catchment, which was the Waterway Creek at a Market Scout camp. For the worst catchment, unfortunately this was the Heathcote River, and this is largely probably due to the urban industrial catchment in those areas. And the worst site was jointly with Linwood Canal, which isn't actually part of the 5 catchments, it's its own catchment, in Hayton Stream. So when we do the analysis, we also look back to when we first started regularly monitoring the sites. So back to 2007 is when we first started monthly monitoring them. And we can look at to see whether the water quality has changed since that time, or over time. So those results in that report showed that most of the sites have remained steady. They're not getting better, but they're not getting worse. But that's not to say that they're at a good level to start with. There were some sites that have degraded a little bit. So for example, zinc in the Avon and the Heathcote appear to be increasing, and sediment and nitrogen in the Heathcote appears to be increasing. There were also some good news, there were some improvements. So for example, phosphorus in the Waterway, and this river has recently won an award because of that. And I think that's mainly due to all the riparian planting that the rangers and the council have been doing in that area, which is buffering the runoff from the adjacent paddocks. So when we look at the water quality, we can see some peaks when the earthquakes happened with bacteria from the wastewater overflows and sediment. But long term, looking back to 2007, it seems that we're back at the same sort of levels as we were pre-earthquake. Although this doesn't necessarily mean that I'm talking about settled sediment, so there is still quite a bit of sediment that is settled in the rivers that we will remove over time, and we have removed many tonnes of it since the earthquakes. So we also look at the quality of sediment, so the sediment that's in the channels of waterways, because they can give you an idea of sort of more legacy contaminants because they stay in the sediment for a long time. So copper, lead and zinc and hydrocarbons are often above guideline levels. And there are also some little hotspots of contaminants that we find in different catchments. One of the ones that's been quite interesting, we think, is related to coal tar. We've been getting quite high levels of hydrocarbons in certain areas. The roads used to be made with coal tar, and it's possible that this is, because of the earthquakes, has come into the system, into the waterways, and coal tar can have quite toxic levels. So we just need to look into that in more detail. Sediment quality seems to be similar across catchments, and there's no real pattern in changes over time, except for we do see across the catchments that lead is reducing, and that's primarily because of the introduction of unleaded petrol. And we do see that zinc is also becoming higher in the sediment in the Heathcote. Those are just examples. So we also do a lot of monitoring of the ecology of the waterways, and we look at a bunch of different measures, and one of the good measures that we use is a metric which sort of tells you whether you've got waterway health of excellent, good, fair or poor based on whether you have sensitive insect species or not. So if you've got high numbers of sensitive species, you'll have an excellent health, and if you have only pollution tolerant, you'll have a poor health. So from those metrics, most of our waterways unfortunately get a sort of rating of poor. They're affected by fine sediment that I was talking about before on the channels. A lot of them have very little shading in the urbanised environment, And shading or riparian vegetation is important for improving the water quality, keeping temperatures down, but also it provides habitat itself to the waterway. It's all part of a package. We also tend to channelise a lot of our waterways, which removes the habitat variation and gives a variety for all the different species to live in. And as I mentioned, the insect communities are dominated by pollution-tolerant species. And then we have a limited number of fish species present. It's not to say that we don't have a lot of some of the species, like eels for example, but that we don't have a massive diversity. But I don't want to get too depressed. There are some really good things about our rivers as well, and we have to celebrate these and protect them as well. So we do have some sensitive and threatened species. We do have some mayflies, stoneflies and caddisflies, which would give you those higher ratings for the stream health. And they are mainly over in the Styx and Otakaikino before, so the less urban catchments. We also have some threatened invertebrates such as the koda and the kakahi, and then threatened fish species such as the longfin eel, inanga, which is a type of whitebait, lamprey and bluegill billy. And the other good thing is that we do have inanga spawning sites. Some of these have been impacted because of earthquakes and other reasons, so we do need to work at restoring those, but we still have spawning that's occurring. So for all of those reasons, we have proposed some of our waterways to be sites of ecological significance in our district plan review. So the health of the waterways is variable across the catchments. As alluded to before, we get higher ratings in the Styx and the Otakaikino. And we have been monitoring regularly these sites for the last decade or so. And generally since that time, there's been no changes. So like the water quality, they're not getting worse and they're not getting better, but that's not necessarily they're at a good level. But we do have some monitoring that we know of back in the drainage board days, and that does indicate that we have lost some of our sensitive species since that time. So what are the impacts on our waterways? So discharges are a big thing, and they can range from stormwater, which was talked about today, and wastewater, and then also industrial and commercial discharges that should ideally be connected to the sewer, and then dewatering water. And this is really, dewatering water is just if you're going to build in an area that has high groundwater and you need to put foundations in, you need to pump the water out to make room for the foundations, and that's called dewatering water. And if they have high levels of contaminants, it goes to the sewer, but then you can also get a consent from ECAN to discharge directly to the waterways, and sometimes there's some whoopsies in terms of sediment, so that can be an issue as well. Construction phase sediment, which I talked about before, that's a really big one that I'd really love the community to get on board with getting on top of that. And then loose sediment from the unstable port hills. So over in the Heathcote catchment, the port hills have a different type of sediment, which is called loose, and it's a lot finer, and so it doesn't settle out as easy and it's hard to treat. And that's what makes the Heathcote look so much dirtier compared to the Avon River when it rains. So that makes it a bit harder in that catchment. And then also as residents, there's a lot of inputs that we do, just by forgetting that the gutter connects ultimately to the waterways. So car washing, cleaning your paintbrushes, fertiliser runoff of lawns, and just litter, and of course road cones being a big one directly into the waterways. As I mentioned before, earthquake-derived sediment as well, and then faeces from waterfowl and dogs, potential predation competition from introduced fish species on our native species, and then also there's macrophyte and bank clearance that we do, which is really important because we do need to do it for the community for flooding reasons and for fire risk, and we also get part of the community that likes to have those open banks. But we just have to make sure we balance that and juggle that with the need of what the stream health needs as well. So for example, thinking maybe a little bit differently at inanga spawning sites, for example. And then nutrient-rich spring water as well. Carl alluded to the fact that there is some contaminants that come up through into the waterways through the groundwater. We've just recently finished a study that's looked at the fact that springs in the upper catchments in the Avon, for example, are bringing nitrogen and phosphorus into the waterways just from having those high levels in the groundwater. So the groundwater itself is influencing some stream health metrics. A lack of riparian vegetation, which I mentioned before, is important, as well as often when we develop a site, we rip out the vegetation and don't necessarily replant it, and there's also a lapse in time from going from shading tall vegetation to having short vegetation even if you replant. Plants with high leaf fall, usually exotic plants, they can add a whole bunch of organic matter to streams which can affect the water quality. Then we also have some barriers to fish movement, which affects obviously the fish being able to move up and down the catchment, such as weirs. And then a big thing that we deal with at the council is intrusions into waterway setbacks. So you actually require a consent to build or do earthworks within our setbacks. And there's for a number of reasons: to prevent hazards, so displacing floodwaters, but also for ecology. So these slides just give you an example of the types of things that we come across. So the one on the left it's really hard to see actually from here, is basically a fence right across the waterway with no gap. So that can have some issues for flooding and then ecology as well, because you need that flow and corridor up and down the waterways. And then the middle one has a retaining wall directly on the right, so that should really be a functioning riparian margin. And then again on the far right, on the left, that should really be a functioning riparian margin to improve the water quality and the ecology. So how can we improve waterway health? And of course there's really my suggestions, so I'm open to any other ones, is reduce discharges. So the City Council is working towards global consents and management plans, and ECAN have catchment projects like the one there, and we try and work with them on those as well. But there's also community projects and things that we can do with that. Educating the community, I think, is a big thing. Erosion and sediment control and stabilisation of soil, that's another one that I think is really big, that I'd really love the community to get behind. Just having people out on the ground to see it and to encourage people to do something better is really important. And then just remembering that the gutter connects to the waterway and changing our behaviour. Sediment removal, I think, will have some really good ecological benefits. We remove some sediment for flooding reasons, but also it has benefits for ecology. The Avon River Precinct, if you've been through there, is probably a good example of quite a few tonnes of sediment that removed to help with the ecology there. Planting riparian margins, ideally with species that are adapted to the area, so native, locally sourced species. Excluding stock from waterways in rural areas. And I know this sounds a bit grinchy, but not feeding the waterfowl so we can help control their numbers. We did notice after the earthquakes, with not having as many people in the city, that our bird counts were a lot lower for ducks. And pick up dog faeces as well, and designing buildings without using copper and zinc products. And the other interesting one is potentially copper-free brake pads, which we've been looking at, but that's probably going to be a legislative thing. But actually in America they have copper-free brake pads because of the effects. Planting unstable port hills and upper catchments, and we do have funding under our long-term plan to do that, so we're chipping away at that. Controlling pest plant species, one of the good ones to do would be getting on top of yellow flag iris at inanga spawning sites. And again, just restricting building and earthworks within our setbacks. And then doing waterway restoration and naturalisation is obviously a big help for waterway health. So the take-home messages that I wanted to give you today was that our waterways are typical of urban areas and they're not great, but we do have some really good important things as well, so we mustn't forget that. We've got threatened species and some sensitive species, so we need to protect them and then work towards improving waterway health. We need to work holistically. We can't necessarily concentrate on just stormwater or water quality. We need to think about what we do for the ecology, so riparian planting and things like that as well. They're all pieces of the same puzzle. And we need to work collectively. We can't necessarily expect that it's a local council or regional council approach. We need to have a shift sort of as a community and get behind it as well. And it will take time. These sorts of things do have lag effects, so even when we do make improvements, it may take a while for us to see that change, so we have to keep that into perspective and then just keep chugging on. And it will take money, so we have to, if we want to get to where we want to go, we're going to have to put some money into getting there. But we are required to improve waterway health. We have national and regional legislation that we have to meet, and the council itself has consenting compliance. But also there is, hopefully with you guys, a will and a drive from the community as well.